Introduction: the ally and the enemy. Chemistry has a lot of formulas that allow us to explore the topics in more depth. Anytime you wrestle with formulas or measurements, you are going to be dealing with units. Despite popular belief, units are your friends. They will make your life easier if you learn to them. So they will make your life easier if you learn to let them do their job. If you fight them, they will haunt your dreams. Haha. Note: as time has become a rare commodity, many schools have phased out the discussion about significant figures. Even I've taken to just telling my students how many significant digits they should go to instead of waiting for them to figure out how many they should be able to get from their particular instrument. As you wade through this course and much of life for that matter, you have to pick which battles you want to fight. Significant figures and scientific notations. Scientific notations, a way of presenting massively large or extremely small numbers to something reasonably readable. Scientific notation follows the pattern m times 10x. Your m value must be greater than 1, but less than 10. Significant figures, besides being pure evil, sig figs are digits that carry meaning. In other words, it's all the digit you know. It's all the digit you know for sure, and one digit that you're guessing at. They're based off the measurements from their actual instrument, whether they are given to you or you are asked to measure something yourself. For example, if you read a graduated cylinder, the tall, skinny glass things your teacher wants you to grab to measure liquids that has dash marks every milliliter, ml, you should be able to get one decimal place. This is because you can be certain up to the millimeter and then have to guess at the last digit, then the tenth of the millimeter. In general, the significant figures are based on what can be definitely measured plus one digit. So, for example, if you have a metric ruler, you can see that if something is 2.24 centimeters, that last digit is estimated though, because there is no definite line for you to measure and see for sure. So one person may look at their metric ruler and say something is 2.27 centimeter, and another say 2.26 centimeter. 2.26 centimeter. I would say in most cases, it doesn't matter which you choose, so long as the rest of your measurements follow consistently. Significant figure rules can be found all over the place. Here is the summary. Non-zero digits equal significant. Zero sandwiched between non-zero digit equal significant. Zeros following a decimal point and a real digit equal significant. For example, 0.0002 has one significant figure, but 1.0002 has 5 significant figures. Trailing zeros are not significant unless there is a decimal point present after. For example, 2000 has one significant figure, but 2000 points has 4 significant figures. Examples. 2,232,000,000 is only 4 sig figs. 43,432,000,000 and 3 is 11 sig figs. 3,443.00 contains 6 sig figs by putting in the zeros after the decimal point, I am deeming them significant. The assumption is that whatever instrument this number was derived from could be estimated to the hundredth place, that second zero. Note, the official abbreviation for the significant figure is SF, not sig fig. Why use scientific notation? If I wanted to indicate the first number, 2,232,000,000 to 5 sig figs, I could simply draw a line over the top of that first zero, the fifth digit if you are counting from the left side. Since this is difficult to show while typing, I will put it in the scientific notations instead. 2,232,000,000 I'm sorry. So 2,232,000,000 to 5 sig things equals 2.2320 times 10 to the ninth power. 10 to the ninth power. Note, when doing problems throughout the course, density, morality, etc., you want to show your final answer to the least number of sig figs. Remember that significant figures are derived from their measurements of some sorts. Common mistakes in rewriting numbers to the correct significant figures. Failing to preserve the place values, tens spots. This will change the number. For example, 235,423 relating to the 3 sig figs is 235,000, not 235. If somebody owed you $235,000 and decided to give you $235, you'd be pretty upset. Not rounding correctly. Look to the digit immediately right of the last SF you are allowed to keep and round. 5 and up, round up. 4 and down, round down. Leave alone. For example, 2,415,487 written to the 3 sig figs is 2,420,000. Because 5 will round up. Mathematical operation. Addition and subtraction. First, line up the decimal points. If I wanted to add 22.46 plus 0.2569, I would need to line up the decimal points. Do the addition and then round to the 2 decimal places, since we are assuming that the 6 in the first number is already an estimated digit. 22.46 plus 0.2569 equals 22.7169 becomes 22.72. Multiplication in scientific notation. Multiply the m values and add the exponents. Then adjust for the significant figures and your new m value. For example, if your problem is 2.5 times 10 to the second power times 5.0 times 10 to the fourth power, you'd take 2.5 times 4 to get your new m and then add 2 plus 4 to get the new exponents. 2.5 times 10 to the second power times 5.0 times 10 to the fourth power equals 12.5 times 10 to the sixth power becomes 1.25 times 10 to the 10 to the seventh power becomes 1.3 times 10 to the seventh power. One part that can get tricky is if you have a negative exponent, then you maybe adding a negative number, in essence subtracting. Division in the scientific notation. General form for a number in scientific notation: m times 10x. Divides the m values and subtract their exponent x, then adjust your new m value to the proper number of the sig figs. Common mistakes in scientific notation calculations. 1. Addition or subtraction. You must make the exponents the same. You do not add or subtract the exponents. 2. Multiplication or division. You must add exponents in the multiplication problems and subtract exponent in division problems. Please watch out for negative signs in exponents. Dimensional analysis, conversion factor method. Conversion factors, a way of presenting a particular equivalent value. For example, $1 equal 4 quarters. Think of it as an equivalency expressed as a fraction. That might sound very fancy, but it simply means that the numerator and the denominator represent the same quantity in the different units. Dimensional analysis. You might hear it's called fence posting. It's just a way of presenting stuff that makes I'm sorry, I made a mistake. This is a tool that allows you to change from one unit to another. It's just a way of presenting stuff that makes dealing with the unit easier. You actually deal with equivalent values all the time. Ever bought something with all quarters? You instinctively use dimensional analysis in your head. Ever saw something with all quarters? You instinctively use the dimensional analysis in your head. Units. The good guys. Units are a measure of the magnitude of whatever you are talking about. They will help you identify the information you are given. One of my worksheets has a candy conversion on it with strange equivalencies like 4 spearmints equal 9 gummy worms. Here, spearmints and gummy worms are units. If I have a certain number of the spearmints, I can find out how many gummy worms would be equal to that amount. The units you use in the class will depend on the instrument you are dealing with. Common units: volume, milliliter, m, capital L, liter, capital L, mass, gram, lowercase g, kilogram, lowercase kg, temperature, degrees Celsius, degree sign capital C, Kelvin, capital K, time, second, lowercase s, minute, min. What's the point? Units will help you navigate many of the formulas because they will help you identify the information you are given. The easiest way to do some of the harder chemistry problems is to get good at the conversion factor method. Step to the dimensional analysis. Step number 1. Write down the number and unit you would like to convert. Starting points. Step number 2. Write a multiplication sign followed by the conversion factor you wish to use. What you go from should go on the bottom, in the denominator of the conversion factor. This is the unit you are converting out of. What you go to should go on the top. in the numerator of the conversion factor. This is the unit you are converting to. Step number 3. Repeat the step 2 as necessary. It might take many conversions to get to their final unit. Right. Step number 4. Once you have obtained the unit you want, solve. Numbers on the top in the numerator are multiplied. Numbers on the bottom in the denominator are divided. This might sound confusing, so let's see some examples. Example 1. Let's just say the current euro to dollars conversion rate is 1 euro to dollar 1.12. If I want to buy something that costs 8.00 euro, I could set up the conversion factor to get from the euro into dollars. So I would know how many dollars to pay. 8 euros multiplied by $1.12 divided by 1 euro equal $8.96. Explanation. The unit I wanted to change from euro was put on the bottom, so the unit would cancel with my original unit. The unit I'm left with, dollars, is on top, since after cancellation, it is the only unit left. Example 2. If I want to buy something that costs $2.50 with quarters, how many quarters do I need? Equivalent value, $1 equal 4 quarters, so $2.50 multiplied times 4 quarters. So 4 quarters over $1, equal 10 quarters. Wow. Explanation. The unit I wanted to change out of, dollars, goes on the bottom in the denominator. The unit I wanted to change to, quarters, goes on the top in the numerator. To solve, I end up multiplying by 4. My final unit is quarters. Example 3. If I have 24 spearmints, how many gummy worms could I get with them? Remember the conversion factor presented above. 4 spearmints equal 9 gummy worms. So 24 spearmints times multiplied by 24 spearmints multiplied by 9 gummy worms over 4 spearmints equals 54 gummy worms. It's like a bartering system. Bartering system. What is this bartering system? If you have excess French fries, and your friend had a pack of cookies he doesn't want, you could work out the price of the certain numbers of fries needed to buy a cookies. If a cookie costs you 8 fries, the equivalency would be written as 8 fries equals 1 cookie. You could then do conversion either starting with fries and ending up in the cookies or vice versa. Example 4. How many cookies could be bought with 40 fries? Equivalent value, 8 fries equal 1 cookie. So 40 fries multiplied by 1 cookie over 8 fries equals 5 cookies. Note, you can string as many conversions as you need together as long as you have appropriate conversion factors, equivalencies. The conversion factor method is useful in chemistry because you can perform calculations involving atoms, molecules, moles, and mass. Common mistakes in dimensional analysis. 1. Not starting with a given. You must start with a given piece of information. 2. Not matching the unit. If you want to cancel a unit, you need to have it on the bottom of the conversion factor. If you want to change to a unit, you need it on the top of the conversion factor. Wow. Okay, let me repeat it again because this is so important. Not matching the units. If you want to cancel a unit, you need to have it on the bottom of the conversion factor. If you want to change to a unit, you need it on the top of the conversion factors. 3. Improper significant figures. The number of significant digits in your final answer should be determined by the starting number given to you, not the conversion factors. So let me repeat it again. Number 3. Improper significant figures. The number of significant digits in your final answer should be determined by the starting number given to you, not the conversion factors. Sure. Density often shows up only in the early chapter of the chemistry course. It's a relatively simple formula. Students have seen it before. It's great to talk about while discussing the units of the measurements and introducing laboratory equipments. Density equals mass over volume. Density can have several different units depending on what you use for the mass and the volume. The most common units for the density in many classes is grams over milliliters, because those are typically the units you use in the lab. Yeah. Common mistakes in the density problems: not writing down the correct formula, not changing the formula correctly if solving for mass or volume, forgetting to pay attention to sig figs.